So in this question, we're told there's two identical blocks, negligible friction. We know that the one block is moving up the inclined plane with V0, the other one's moving down the inclined plane with 0. And this is defined as the positive direction this way and negative direction that way. So what we would know, and one way to approach these complex systems where it can be confusing, is to simplify. This is easier to understand if we have two blocks like this moving toward each other. And we could, since they're identical blocks, we could say this is the center of mass. Since they're traveling at equal speeds, this one will move to that distance in that time, and that distance in that time. The center of mass will remain the same. And the reason for that is that this system, there are no forces acting on these blocks, or no external forces. Sure, we have the force of gravity and the force normal. They are equal and opposite. So there's no net external force. Those are balanced. And since there's no friction, there's no next external force acting on that. However, if we view this on the inclined plane, the center of mass, which at a moment in time we might define as being right here, is experiencing a net force. And that net force is this force of gravity that's causing it to accelerate down the plane. There is a component like so and like so. So this FG parallel is pulling it down the inclined plane. So while if there were no gravity, the center of mass would remain the same. But because there is an external force acting on this system, an unbalanced force, a net force, an unbalanced force acting on the system. Now, gravity in this system, remember, is balanced. Now that we're in this system, it is no longer balanced when it's at an angle. So there's a net force on the system, and that the center of mass of the system will move down the hill, and therefore it is the center of mass velocity of the system will not be constant and not zero. It's not constant. It's not moving up the hill, it is moving down the hill. And again, that's because when we look at it horizontally, there is no net external force. But when we look at it going down the inclined plane, the net external force is not zero, and therefore there's acceleration down the inclined plane.